Hello, in this video we're going to look at example 6 from the chapter 6 review worksheet from the Lock 5 Unlocking the Power of Statistics textbook. So in this example, a percent tip was analyzed. So there's 157 different checks or bills from the First Crush Bistro in New York State. And out of this 157 bills, 106 bills were paid in cash. And those cash bills, the tips were an average of 16.39%, standard deviation of 5.05. The mean percent tip left on the 51 bills paid with a credit card was 17.10%, standard deviation of 2.47%. So we want to test to see if there is a difference in the mean percent of the bill left as a tip between bills paid with credit card and versus bills paid with cash. We're going to use a 1% significance level. Okay, so I'm gonna go to my formula summary sheet, and it says, I think pretty clearly, we're looking at a difference in the mean tip, difference of means. So if we scroll down, we actually technically have 3 different scenarios for difference of means. Independent samples, where we know population standard deviation. Independent samples where we do not know population standard deviation, and then a scenario where the means are paired up. So we got to figure out which of these to use. Okay, so let's first write down the parameters. That might help us decide what we're doing. So is a mean. I'm going to let mu sub 1 equal the mean tip percent on bills paid with cash at First Crush Bistro. And let's let mu sub 2 equal the mean tip percent on bills paid with credit card at First Crush Bistro. Okay, so we have our 2 parameters, and then we could write our hypotheses. Oh, but wait, let's wait a second, because we need to figure out if it's a paired difference or independent difference. So sometimes it's nice just to think of the summary statistics. So here I've got 2 different samples. So I've got n sub 1. That's my sample size for bills paid with cash, 106. A sample mean of 16.39%, 12% time. And then S sub 1, my standard deviation for the bills paid in cash, 5.05. And if we look at the second group, in sub 2, the bills paid with credit card, they're 51. The sample mean for those were 17.10. And the standard deviation for those credit card bills were 2.47. Okay, so just to note, we've got 2 different sample sizes. So it cannot be paired. We're not looking at a paired scenario. We have independent samples. I'm going to put a note on here. Since sample sizes differ, we're doing a difference of mean independent samples t-test. Let me add something here. Since sample sizes differ and we only know sample data, we are doing difference of mean independent samples t-test. We're going to use t instead of z. So now let's write down our hypotheses. The null hypotheses are that these 2 sample means, or excuse me, population means are equal. And for the alternative hypothesis, That's right here. We want to test if there is a difference in the mean. So when we go back to write this up, we're going to set mu sub 1 not equal to mu sub 2. So there's my null and alternative hypothesis for this scenario. And I got hypothesis, assumptions, requirements. Let's write that up. So I put those on the second page of the formula sheet. And we're looking at difference in means. We need the sample sizes to be at least 30, or both population distributions are normal. Again, we don't know anything about the population distributions, but we do have two sample sizes bigger than 30. Since both sample sizes are bigger than 30, they are 106 and 51 respectively. Just to note, the requirements are met. Okay, got that part done. And now we need to look at our test statistic. And for that, t, we're looking at the t distribution. If I go back up here, t is x bar 1 minus x bar 2 over the standard error. So this is over line x over that standard error. And if I were to compute this, this would be x bar 1, 16.39 minus 17.10, and that's going to be divided by the square root of the two sample standard deviations, 5.05 squared over 106. And the other standard deviation is 2.47 squared. And we're going to divide that by 51. And I'm going to plug this in my calculator. And I get about minus 1.1829. I'll round that to 183 for my test statistic. All right, so I got to use the formulas. I've got my test statistic. And for p-value, I do need to know the degrees of freedom. Degrees of freedom is n minus 1 for the smaller sample size. So 51 minus 1 equals 50. So we need that to get my p-value and decision. To get the p-value, I need to go to stat key and look at the t distribution. I'm going to go out to the main screen, click on t distribution. I have 50 degrees of freedom. And I forgot to make a comment on the note sheet. Since alternative hypothesis is a not equal, make sure to click on two-tail. We're doing a two-tail test. And my test statistic was negative, so I'm going to go on the negative side and change that to minus 1.183. Click OK. And p-value is going to be both of the tails combined, or I could take 0.121 times 2. So p-value is 0.121 times 2, or about 0.242. About 24% on the p-value. And we are going to compare that with a significance level of 1%. This is significantly higher. We do not reject the null hypothesis. All right, so the last thing we're going to do, we do not reject the null because our p-value is greater than 1%. And I want to write up a conclusion in as plain English as possible. This sample, or this experiment, let's say this sample, does not provide strong statistical evidence that there is a difference in the mean tip percentage between cash and credit card bills at First Crush Bistro. So there's a little bit of a difference, but not very much. It was less than $1, and standard deviations weren't too big, and fairly big sample sizes. So we do not have evidence that there's a difference in the tip percentage amount.